So today we are going to discuss about the mirror formula for convex mirror. So previously we have done it for concave one. Okay, so in convex mirror, as we know it very well, that convex mirror is also known as diverging mirror. So of course all ray will diverge. Okay, so there will be no real image form in case of convex mirror. So at this particular time we can say only two cases will arise in case of convex mirror. So only two ray diagram you need to practice. One is the object placed at the focus, and another one is the object placed anywhere rather than focus. Okay, so we will take the after one. Okay, so I have chosen one object AB, and we need to take at least two rays to make at least one image, right? So one is parallel to the principal axis. It will go in this direction, and of course it will pass through focus if you proceeded behind. Okay, another one, it will pass through the center of curvature, right? So in this way you can draw it, right? So a prime b prime will be the image formed by the object AB via the convex mirror M. Okay, so here we need to draw a simple thing. We need to draw a perpendicular from the point M to D, okay, on BC. Now, we have already discussed about how to choose this type of triangle and to make them similar. So we need to take a particular point. And that particular point should enclose as well as image and object. Okay, so we have chosen focus and center of curvature. Okay, so let me discuss it one by one. If I choose the point C, then C, A and B, this triangle, it enclosing object and center of curvature, and C, A prime, B prime, this is enclosing image and center of curvature, right? So we can prove the similarity between these two triangles. Another one, see, here I have drawn a perpendicular, of course purposefully, and that height of the perpendicular is just similar to the height of the object, right? Now see, if I'm choosing the point F, then F is enclosing MD, which is of course analogous to the AB, and of course A prime B prime, which is analogous to, which is of course image, right? So now we are going to find the similarities. First of all, MPF. Okay, we have another time we have discussed that the point P and D is similar points, right? If you are not understanding this matter, please go through the previous video. We have discussed it in very lucidly and elaborate way. Okay, so between this and these two triangles, height by height equals to base by base, right? And in place of MP, we can write AB because these two heights are just similar. On the other hand, for these two triangles A, B, C and A prime, B prime, C, these two triangles, height by height, and base by base, right? Now after getting this, these two terms on the left hand side are equal, so we can equate the right hand side. After equating this equation, we have this thing. Now if your all the quantities presented here are not belong to V, U, F or R, okay, then you have to write it PC equals to R, then you have to write it from the pole, right? In previous video we have discussed it. And suppose FP, so I have written FP and it will represent F, and in case of B prime F, I have write it in this way, PF minus BP prime. I'm just showing you once. BF prime, okay, BF prime, we can write it PF minus PB prime. Now PF is F only, and PB prime is V only. Right now, after doing all this, just put your sign convention. According to your sign, you have to place all of this. And after that, I have done the cross multiplication, and in this stage you have got this type of line. 2f will be cancelled out and this 2 will be added. So this type of structure you will have in the before last line. After that, you have to divide it by UVF. You have to divide this equation by UVF, and you will get 1 by U minus 1 by V plus 1 by F. After that, if you arrange this one, you will get 1 by F equals to 1 by V plus 1 by U. Okay, I hope this is clear. So first step, you have to choose two distinct points that will enclose the image as well as object. Okay, after that, you have to prove the similarities between those. After that, if any of them are not along this U, V and F, and of course R or 2F, then you have to write it from the pole, either in addition or in subtraction. In any way you have to write it. After that, you have to put the quantities, physical quantities, along with their signs, and here you go. Okay, so the next thing to discuss is about magnification. So I have discussed it earlier that we need to learn here about two different magnification. One is linear magnification and another one is, of course, angular magnification. So linear magnification and angular magnification is what? See, linear magnification, you can write it in this way: height of image divided by height of object, right? So this is a pattern, you can write it in this way. And also image distance by object distance along with their signs. So this thing I think you have done in your class 10th examination. Just we will discuss the different phenomena in which the value or the sign will say what will be the type of the image which is formed. Suppose if the value m, see, of course the value m for linear magnification, it could be in positive or in negative. So if I take the modulus of it, it will become surely positive. Now if the magnitude, if I'm taking the modulus, mean the magnitude, I'm not depending upon the sign. Just if the magnitude is greater than 1, that means it is magnified. If it is less than 1, means it is diminished, or less than the size of the object. If it is equal to 1, then it will be same sized. Okay, now here I'm taking two different type of examples. How a magnification of a particular lens or mirror, not about lens, of course a mirror. Now we just discuss about mirrors. How this magnification will tell about the nature. See, this is -3, right? So minus here indicates, suppose this is your mirror and this is principal axis. Okay, if the object is formed in that direction, it will always positive. If it is below the principal axis, it will become negative. Means what? If it is upright, object always placed above the principal axis. Now if object and image both are at the same side of the principal axis, it will be called upright or erect in other language. But if it is just in opposite direction, means below the principal axis, it will contain a minus sign. So we will say inverted image will form, right? So minus means inverted, and inverted comes with another term called real, right? Whenever we are saying inverted, it always included the term real. So here from the minus sign, we can say that the image form that is real and inverted. And what does this 3 signifies? This 3 signifies it is greater than 1, right? So it will be magnified, right? So we can say from the magnitude along with the sign, whatever the nature and the size of the image says, right? We can say it. So this is your homework. Tell me what will be the nature and what will be the size of the image formed by the object. Okay, I think you can do it.